Hey everyone, my name is Ayush, and today I'll be discussing the nearest diet challenge given by Hitesh Choudary as part of the Saturday coding challenge. So let's get started. Okay, so let's discuss the problem first. So in this problem, we have a family, and this family just loves eating cookies. Okay, now the order in which they sit depends on the number of cookies they ate. So let's say one of the family members ate 100 cookies. Now, if another person comes and says he ate 150 cookies, he will sit somewhere higher than this guy. Okay, so he'll sit a bit higher than this guy at a position that is higher than this guy. Similarly, if someone comes and tells that he ate cookies less than this guy, he'll sit at a position lower than this guy. So this guy came and said he ate 30 cookies. So the rule says he has to sit at a position lower than lower than this guy. Okay, and this applies to each and every member of the family. So if someone comes and he says he ate higher than this guy, he'll sit at a position higher than this guy who ate 150 cookies. Similarly, if someone comes, says he ate cookies less than 150, he'll sit at a position less than lower than this guy. So just like this, and this applies to each and every node. So here also the same rule applies. Now suppose that a new guy comes in and says that he ate X number of cookies, let's say 130 cookies. Okay, so our task here is to find a family member. So we have to find a family member who ate the same amount of cookies as this guy or the nearest amount of cookies as this guy. So in this case, the nearest we don't have the same family member who ate same number of cookies, but the nearest amount of cookies is eaten by this guy. Okay, so in order to solve this problem, I'll be using a binary search tree. So it's going to be a recursive process, and in each recursive step I will start with the root node, and at each recursive step what we're going to do is we'll compare the current node. If I start from the root node, it will be this one, and I'll be comparing this node with this node. If this node is greater, then I'll move to the left subtree. If this node is smaller, then I'll move to the right subtree. And that would be basically what we do at each recursive step. So once I move to the right subtree or the left subtree, the process will enter the subsequent step of the recursion. But before moving there, we'll do one extra step, which is we'll store the difference between these two values in a dictionary. So the value of the dictionary, each element of the dictionary will be the difference between these two values, and the key will be this element. Okay, so that we can track which is the minimum, which person has minimum or the nearest diet to this guy. Alright, so let's have a look at the code. I've written it in Python language, but it can be done in any language. So as I told you, I'm going to use a binary search tree. Here I have written a class which will be used in the as the node of binary search tree. So its object will be the node of binary search tree, and it has some methods. This one right here is the constructor. It will initialize the values of this node, Then we have a method to insert a node in the tree basically. And yeah, this complete method is to insert uh, a node. So what's happening exactly in this function is that it will check if the value of the node is greater than the value of current one. If it is greater, then we'll put the node we are inserting to the left subtree. Otherwise, we will put it in the right subtree. And this step right here, it is basically a recursive call. So if the node to the left is not null, we'll have to put the node further down in the tree. So for that, I'm calling it recursively. Okay, so this part right here is the continuation of the uh, node class which we saw in the previous slide. So here, this part is actually the meat of this code. This is basically the part where I'm doing all the recursive steps that I discussed while I was explaining my solution. So here, this value is basically the value which we of that new guy who for whom we are trying to calculate the nearest diet. And this d is an empty dictionary. In the beginning, basically we will pass an empty dictionary here, and we'll use it to store the difference between the current node and the value of this value. That so here I'm checking the values of the two values, and if the current node is greater, I'll move to the left subtree. If the current node is smaller, I'll move to the right subtree. But as I said before moving, I'll store the difference between the two values in a dictionary. So that step is right over here. Here, right over here, I am calculating the difference between the two values, and this step is actually, it might seem quite complicated, but it is actually very simple. Here I'm using a ternary operator basically, so that the value stored is not a negative value. Okay, and same thing over here. I'm storing the difference between the current value and the value for which I'm finding the nearest diet. And once this value is evaluated, I am moving to the next node, right or left, recursively. Okay, so that's it for and once all the recursive steps are over, I will return the dictionary. So from that dictionary, we will evaluate whether um, we found the same node as the new guy, or will find the nearest node. So here in this slide, I have written the a class for binary search tree. So this class basically uses the node class to construct a tree, and this method basically it's doing is just simply calling the methods of the node class, and same with this method. Here this method is calling the insert function or insert method of the node class. This method is calling the search method of the node class. So it is a very basic class, and all the methods are very basic, nothing complicated here. Let's move to the next slide. So from here, the execution of the program begins. The first step I'm doing is constructing an object. Basically, I'm creating an object, BST object. Then this step is to take the diet of the all the family members as an input. Okay, so it might again seem a little bit complicated, but it's not. So let me break it down for you. This step right here, this input, and then this entire string, then dot split. So this entire part is actually the a method in Python through which we take space separated inputs. Okay, now in Python, every input that we take is actually a string, so it in integer format. So for that, I'm using this function, this map function. What it does is it takes each string of the all the input strings, and it converts it into an integer. That's why we pass so you can see the two arguments I pass here. First one is int, which is the type in which I want to convert it, and the second argument is the input dot split method. Okay, now the map function will not return a list, it will return an object, a map object actually. So I need it in list format, that's why I'm using this method, this list method, and this method will convert it into a list, and in this way I'll get the array as the input. So it is actually very complicated, but I tried my best to explain it to you. If you have any doubts, um, put it down in the comments. I'll be happy to resolve your doubts. Okay, moving on. I'm adding all the elements that I got here in the tree. Okay, just calling the method to insert the element, and I'm using a for loop to traverse each element. Okay, again very simple step. And the next thing is that I'm taking the diet of the new guy who came later after everyone actually sat the way they were meant to sit, will be taken in this step. Then we are going to search for the nearest diet, or the whether we get an equal diet or not. This will return a dictionary, as I explained. Now we are going to traverse through the dictionary and find the key and value where the difference is minimum. Okay, and if the difference is zero, that means that we found the same element. Okay, means we found the person who has diet equal to the new guy's diet. Okay, so for that I did some basic, variable declarations, and I declared some values for the some variables. Okay, so min is actually to keep track of the minimum, to keep track of the minimum difference that we are trying to evaluate, and key and value keep track of the minimum differences, key and value. Okay, then here we have a loop where we traverse through each element of the dictionary. We check if the current element is less than min. If it is less than min, then we will set the minimum to this particular value, and the key and value to the current key and value basically. Okay, now this is the final step. If here I'm just checking if we found the same value or the closest value. As I already told you, if we find difference will be equal to 0, and I'm checking the same over here. If the value is 0, then I'll print same value found, otherwise I'll print closest value to the key is found, and I'll print it over here. So that is the complete code. for watching. So before ending this video, I just wanted to show you the running. I just wanted to run this code and show it to you. So let's do that. This is the code right here. I'm going to execute it. Let's give some input. 100, 150, 30, 20, 50, 250 and 120. Now we have to enter the diet of the new guy. So I'm going to put 130 here. So it gives the value 120. The closest value is 120, which is the correct answer. The difference, and this guy is 10, which is the lowest. So it gives the correct output. Let's run it one more time. So I'm going to use the same values, but for the new guy I'll enter 120. So here we have a person in the family who ate same number of biscuits as this new guy, so it's printing same value found. So that's it for this video. Thank you so much for watching. If you have any doubts, please comment it down. I'll be happy to resolve your doubts. And the code link, I'll link the entire code in the description. You can have a look at it. So thank you so much once again. Subscribe to the channel, like the video if you liked it. Thank you so much.